Hey everyone, first time live streaming, so just going to do a few little things to sort of make sure it's all working. This look may look like a mess, and if you think that, you would be right. Every so often I see engineers that have clean, neat, organized desks, and frankly, I don't trust them. What I'm going to do is connect on my laptop, which is just out of sight here, and that way I should be able to see whether it works. Hey, Sam's already here. Can you hear me okay, Sam? That's great. I've got a fan on because it is muggy as hell. So the fan's kind of behind me, but I'm not sure if that's like affecting the mic at all. I know I'm a little early with this stream, but to be honest, I was expecting a lot more problems. First time trying anything is always going to be weird. So not that I'm expecting anybody to show up, but I might wait a little bit to see if anybody else shows up. Sorry I missed your stream this morning, Sam. I did catch it after you'd finished streaming, but man, that's so cool about the award. I'm sure I speak for everybody that follows your streams when I say I'm super proud of you for winning that. It was well deserved, absolutely well deserved. I'm horribly and woefully underprepared for this. I shouldn't have been a shock, mate. Need to give yourself more credit, but I'll tell you what, how perfect was it that it had the monetary reward and you managed to restock your belts? I got my own restock this morning. I sent Josh in South Australia a little care package recently, and in it I put a Beglary. It's sort of like the original fidget spinner. Yes, I did see what he that was quite a kingly gift, and to be honest, as much as I'm sure it's going to be absolutely terrifying working with those scales, I really can't wait to see what you do, man. After the quality that you put out for that show, working with materials like that, it's going to be ace. Love to see you actually make one of those with a Damascus blade. I'm not a huge fan of Damascus, but I'm a huge fan of you, so I'd like to see what you do. But yeah, I was talking about the Beglary, that it's basically two small weights on a string, and they've been using them for thousands of years. It's sort of just this thing that you sort of flip over your fingers, and you can get quite acrobatic with it. I'm terrible at it. I don't have the dexterity, but as you would know, when you do any sort of forging, you start getting the aches and pains in the hands, and keeping them dexterous, most doctors and physiotherapists will tell you keeping them dexterous is what will strengthen them and prevent that sort of thing from happening, and things like carpal tunnel and RSI that can happen from using your hands a lot. So I sent him one of these Begleri, and I made mine out of paracord. Actually, you put glass marbles as the weights, and I wrap them in like monkey fist style paracord wraps connected by paracord string. And I actually made my last batch of Begleri. I used up all the paracord that I have, and Josh is like, oh yeah, back in the day I used to make paracord survival bracelets, and he did it before China was mass marketing them, and he was selling them. So he had like an industrial scale sort of paracord bracelet business going. And oh, piano and guitar, cool. I'm a guitar man myself. I've got my Gibson SG right here. So yeah, he was making the paracord bracelets back in the day before they were cool, you know, hipster style, and you know, selling them and doing well with it. And then China started to mass produce them, and as you probably know, you can buy them for like $1.50 from China. So nobody wants to buy one made by a local maker, and he had bucket loads of paracord just sitting there gathering dust for the last like 5-10 years. And he said, oh, if you're making the Begleri, I've got a little bit of paracord for you. I'm like, a little bit of paracord, cool. I can make they only use a little length, so that'll be good. And I'm like, what, is it like offcuts and things? And he goes, yeah, something like that. Anyway, in the mail this morning, turns up this like 2-kilogram bag of whole like 100-foot spools of paracord in every different color. I love Josh, man. He's so generous. It's so cool. He's actually messaging me now. Oh, he's gonna get one of my shirts. That's cool. I should put a link to my merch in the bottom. Yeah, he is a hero. Between you and him, like, this like cycle of care packages that sort of started up between us all now, and frankly I love it, because there's always something that one of us can do that the other ones can't, and or does in a way that the other one likes, or there's something that's like you're at a shop and you think, oh, Sam would like that, or something like that, and it's this kind of like bro circle. It's awesome. So yeah, I suppose I should probably be doing some work right while I'm doing this. I'm not really expecting people to show up, to be honest, because it's me. I've got like 7 subscribers or something ridiculously small, and they're all your subscribers, so it's cool. But really, I'm not planning on doing the events for the live factor. People are just going to see it afterwards and get to have a watch. Now, oh cool. I'm looking forward to that. I'm looking forward to seeing what you send me. It always makes my day. It blows my mind. Haven't been the luckiest person in the world with really close friends or people who do generous things to me. But I tried to be a person, and I learned this from my granddad. I tried to be a person who is generous as much as possible, because it eventually comes back around, and it's sort of, the blacksmithing community is where it's starting to happen, and it's really cool. I really like it. I mean, I know there's still a lot of competitive assholes in that community, but we're not 2 or 3 of them, you know? It's just nothing but humility and modesty, and that's really cool. So, even though we're separated by a country, Sam, I feel very lucky, very lucky. And one day I hope to meet you in the flesh and thrash you at a game of poker. Alright, so for anybody that may be watching this later and not live, normally I do blacksmithing and carpentry. Not much of a knife maker like Sam, whose channel you should totally follow if you haven't already, Sam Towns Bladesmith. Check out that. However, every so often I have a see a need, fill a need moment, and I build something. I have a big background in a lot of things. I'm sort of like the jack of all trades, master of none. I've done martial arts instructing, I've done carpentry, I've done timber framing, I've done agriculture, I've done robotics, I've done psychology, I've done writing. I've been a professional magician for years. I try and do everything. Ever since I was a kid, I was obsessed with knowledge and just learning as much as possible. And electrical engineering, particularly robotics, always was fascinating to me. And I really just sort of did it as a hobby, but then I found out that if you learn just some basics of it, one, you get a new obsession, which is very expensive, so I don't recommend it if you don't have much money. I used to, back when I was working full-time as a behavioral game theorist, I was able to afford all this stuff, so it's still with me. But what I found is that every so often the need comes up for something that doesn't exist, and you think, it would be perfect if I had this thing, and so you obviously do the thing everybody does, and you go onto like eBay and Amazon and all that sort of thing, and you look for it, and you find out that not only does it not exist, but nothing even close that could be modified exists. Yeah. And I ran into that problem. Now, I'm not the only creative one in my house. My wife, who you should follow on Facebook and Instagram, her name's Nissa Handcrafts. She is a henna tattooist, and if you're not familiar with henna, the simple version of it is that it is a temporary tattoo system made of all natural ingredients that's actually drawn onto the skin rather than sort of a drawing done and then applied and then, like those old school, the temporary tattoos you used to get in the 90s. It's not like that. You actually draw it onto the skin, leave it there, and it seeps into the pores of your skin and dyes the pigment. It pigments the skin. That's the simple version. The complex version is that it has thousands of years of deep cultural history in many different cultures around the world, and there's quite a solemnity with the process and the art form. My wife's been studying it and giving it due respect, and rather than buying henna pre-made, she makes it herself from all natural ingredients, does it organically, does the whole thing. Now, when you are working with henna, some people use like a paintbrush, but you can't quite get the effects and everything. But the most common way to apply it to the skin is you build a cone out of cellophane, and you fill the cone with the henna fluid, which is kind of like the consistency of honey, I suppose, would be the closest thing. Or it's possibly like icing, cake icing, before it's set. It's thick and goopy and sticky. Anyway, you fill the cone with that, you twist off the top, and then you nip a hole in the point of the cone, and you basically hold it in your hand and squeeze to apply it while drawing it onto the skin. And it's normally done that way because people usually just have henna done, like usually for wedding ceremonies and things like that. Yes, as Sam just pointed out, henna powder is actually used to create natural hair dyes, which is also a very common cultural thing. Hold on, I'm just getting a text. So usually, especially in sort of Indian culture, weddings and special events, the bride, for example, will be done with henna tattoos and things like that. So it's sort of done in a small space of time. When you are doing it all day, squeezing that cellophane henna tube, they call them cones. So I'll try and use that nomenclature because it's easier to say. Doing that all day, especially if you're at somewhere like a market, like where my wife does the henna tattoos, it's a recipe for RSI. And when your hand starts getting sore, you start shaking, and especially in Queensland heat. So my thought was, surely there is a better way to apply henna that does not require mechanical action of your hand that puts it under strain. And so I looked up, since henna has been around for thousands of years and is quite popular and done at markets quite often by people, I looked up to see whether or not there was a solution for this, and I was very, very disappointed, to be honest, because nobody has thought to make this a little bit more high-tech. People have put it into sort of like an airbrush sort of thing, where you've got a little canister, and it hooks up to an air compressor and pushes it out. However, you sort of got like one speed with that, and henna, when you're using cones, for example, the harder you squeeze, the thicker the line is, and lighter. It allows you to do more texture and more detailed imagery. So the airbrush solution isn't really fantastic. Plus, you're going to lug around a small compressor, which is the power requirements of compressors, even portable ones, is not good for when you're walking around markets. So I thought, well, I'm going to make something, and I, due to many unfortunate circumstances, spent a lot of time in. I thought that, but the traditional application method of henna is with the brush. So the cellophane cones are very much a modern thing, since cellophane's a fairly modern invention. And really, for an entire arm to be tattooed from fingertips to shoulder, you'd be looking at an amount of henna that could fit on the surface of this button. It goes really quite a long way. But if you were to be doing, say, 20 people over the course of a 5-hour market, you need quite a bit of it. So that's where the cellophane cones come in, because it holds about 60, 70 grams of the fluid, I suppose it's the fluid, in there. And being able to carry that amount, you could say, well, maybe use the brush and then carry multiple batches, but you've got to actually try and preserve it airtight as much as possible and temperature regulated, because different levels of humidity and temperature affect the flow rate of the henna. So the application device needs to be able to adjust dynamically to fit the flow rate that will occur based on the temperature and the humidity of the ambient environment. Now that sounds like a really complicated requirement. However, when you're dealing with a cellophane cone, the application speed is controlled by human mechanical action of the hand, which can be dynamically shifted, and basically the common lay term for it is that you get a feel for it. So if I'm going to build an application device, I need something that you can actually accurately replicate the ability to have a feel for it and have that sort of precision of control to be able to make it flow faster or slower, not just based on the thickness of line you need, but the thickness of the liquid. Well, I was thinking pedal driven like that. However, that is extra bulk. So what I ended up coming up with, and the design process of this whole endeavor has actually already been done. So what it's going to be is actually trying to see whether or not I can turn my idea into a real life thing. What I did was I thought of a pen, like a pen like a gizmo, something that rests in the hand comfortably, that isn't heavy, is nicely balanced, is comfortable to hold for a long time, that actually has a pressure sensitive button that is very easy to press. And I mean something that's so sensitive that it comes down to a feel thing that controls the flow rate. And so, yeah, a bit like a 3D printer pen. However, to be able to accurately dose, I'll show you first what I came up with. This is the template base. Now this will be recreated nicely out of a very pretty wood, because if you're going to make something functional, why not make it beautiful? And you'll find that's a recurring theme in all of my projects. It's basically my goal in life, is to make beautiful versions of functional items. So this is just a little template that I made. Now I made this by cutting out a square of paper and getting my wife to hold it in her hand like she would hold a pen. And I got her to actually hold a pen, and then I would remove the pen, and I would put the piece of paper in until it hit places, and I would see where did it hit, and I would remove a bit of the paper and remove, and over the course of about 20 minutes we created a shape that perfectly fits her hand. So my hand's quite a bit bigger, so it's a bit cramped, but basically it hooks over there and she can hold it like this. Now, running out of the nozzle of this is going to be a standard plastic henna nozzle, because they put it through little cone-shaped plastic nozzles that would attach to the bottom of the cellophane cones. Now, running to this, I actually thought, why not use a dosing pump? It's the technical term is a peristaltic pump. Normally, a pump would work by either pushing fluid from behind, as in like a water pump that you can see attached to a tank, puts it through what's called an impeller and forces it through. So basically the water moves through the pump only because there is water building up behind it. That doesn't really work because the material is too thick and thus it's quite heavy. So I thought maybe a vacuum, but then creating a vacuum, even in a small space, takes a lot of power, and this thing has to be nice and portable. So peristaltic pumps, which this thing is here, are usually used in the medical field because they are very, very good at accurately pushing doses of, say, medicine down IV lines. Now I'll open this up and show you how it works. And I'll try and open it up without it going everywhere, but you may get to see that happen live. Okay. Let's see if I can get the light a bit better on this. If you see in there, the tube goes up and around, and there's 3 rollers in a triangle fashion. And when the center axis spins, it pushes the rollers around. And because there's 3, there's always a space in the tube that is actually sealed on both ends. So it grabs a bit of whatever's in the tube, even if it's just air, and pushes it around and then adds it to the stack that is in the other side. Because it's not a vacuum doing it or some sort of pumping system, it's literally just a mechanical motion. It makes the entire process incredibly stable and, most of all, incredibly precise. So what I really like about it is because it will even grab air if it's in there. When you've got this hooked up, one end to your henna gun and the other end to a tank that's holding the henna fluid, as that's turning, that starts sucking air, which means it creates a vacuum and sucks the henna through all on its own. And this can actually go up to like a meter away because it's going to turn anyway, and the amount of difficulty it has turning, it doesn't really change much. So you can have quite a small, light, low voltage motor attached to it, and it ends up being quite effective. So I've got this little gizmo, which is basically going to rest at the back of the pan, like this, creating a nice counterbalance, because if the entire thing's balanced well, it won't tire out her hand and wrist while she's using it. So yeah, peristaltic pumps, usually you'll find them in things like dialysis machines or hooked up to intravenous drips in hospitals where they've got like a saline flow going through, for rehydration, and they have to put in very precise amounts of a medication into the saline flow at intervals. So basically they've got a computer that would have one of these and also a flow rate detector that can tell how much fluid has moved past it. And with those 2 things together, you can very, very accurately and precisely dose things. So my theory is, and I have tested putting henna through this before, which is why the ends are kind of brown. I don't know if you can see that. Henna dyes anything it touches, even wood, which she's actually been doing some cool things with things I've built. So anyway, the henna will flow through this, and the speed at which this motor turns will determine how fast the henna flows through it. Now, how to control the speed in a way that won't cause the same RSI strain that anything else would. Now, normally you'd have maybe a pressure-sensitive button, or I had thought perhaps a lever that as you bend it down, there's things in electronics called potentiometers, which is sort of like a knob, and as you turn the knob, you can read at what position the knob is at. So I'd thought of all of that, but all of them require, it doesn't seem much pressing at once, but if you're doing it all day constantly and having to hold down pressure on it for extended periods while doing long lines and things like that, that ends up being quite draining and could lead to muscle soreness in a finger and things like that. So what I found is this. This is called an FSR, or a force-sensitive resistor. Now basically a resistor works a little bit like if you were to be pumping water through a garden hose and you squeeze part of the hose, the stronger the resistor, the tighter the squeeze. So the water, the voltage in this particular metaphor, the flow slows down. So if you have a one of the pins on a computer putting out, say, exactly 5 volts into a force-sensitive resistor, and then measuring the output on the other side of the force-sensitive resistor, the computer can actually read how much force is being applied to this resistor. Now this thing is very small, as you can probably see. It comes in a tiny packet, but the packet itself only is mostly air. This thing is so small, and the surface area is about the surface of a pea. If I was to hook this up to a microcontroller, it would be able to detect a pin dropping on it. But it could also detect me stomping on it. Anywhere in between. It's sort of an infinite level of sensitivity. I'm only interested in very, very sensitive touches. Because basically, you'll see on this template that I mocked up, I have a little circle here. That is where her finger naturally sits. So what will happen is, as she applies pressure to this point, where the force-sensitive resistor will be, the computer will know how hard she's pushing. Now, the range of pressure that I'm going to put in there is going to be very small, so there's very little force that she actually needs to apply in order to get the thing flowing. Even at high speeds, the maximum force I'm going to have in there is actually just a very light touch. And so she's going to have to train with it to make it be more of a feel thing. And it's little subtle interactions like that which actually make or break a device, really. Anybody that you've ever met that does competition shooting will probably be able to corner you for like an hour lecturing you on the sensitivity of trigger settings. Anyone who takes shooting seriously will they'll spend hours agonizing over how sensitive the trigger is on their firing mechanism. And it's because that trigger is the user interface between you and the device. And this is no different. This is going to be essentially the trigger, but it's going to have a direct correlation between the amount of pressure that she's putting there and the speed at which the motor turns. So if she's not pressing it, it won't turn at all. Hey, state champ. I've done competitive shooting and I know how difficult that is, so that's pretty cool. Maybe we should go shooting if we catch up. I'm quite a good shot. My missus is also quite a good shot, although she's only been a couple of times. I think it's in her blood. Her father was a national champ for rifle work, I think, for a while. He had trophies everywhere. And yeah, I think it's just in her genes, which is cool. So what my plan is for today is, this is the template that I'm using to sort of fit things up. This is my force-sensitive resistor. This is going to be the brain that controls everything. This thing that I'm wiring up at the moment is the thing that allows me to, it's pretty simple. It looks complicated and like an octopus, but this is basically a device I'm building that allows me to connect the brain of my device that I'm building to a computer in order to write software for it. Because there's going to be a lot of tweaking that needs doing. And of course I've got my peristaltic pump. So all in all, the build is quite simple. The actual tuning and tweaking and honing process is what's going to take quite a long time. Probably won't be used to using this thing. But in the early days when she's getting used to it, it's going to be her learning to get a feel for this thing. So I had the thought of putting in 3 little light bulbs. So when you first just ever so slightly touch the sensor, the first light bulb will come on. When you start pushing a little bit harder, the second one will come on. When you push to the hardest that I'm going to allow it to be pushed, the third one will come on. And that will be in real time. So not only will she have the speed of the flow to measure how accurately she's dosing this henna paste out, she'll actually have a visual indicator as well. The reason I'm going to leave it in there rather than just make it a temporary thing that I can then take off later is because it does actually add some sort of, the term in the theatre world is secondary motion. Secondary motion is always makes things more attractive. It's sort of like if you have a Muppet moving around as a puppet. Sure, they've got a lot of motion from what the puppeteer's doing, but the secondary motion would be something like giving them flowing hair. So when they go like this, there's the motion, the primary motion, and then the secondary motion of the hair whipping around. And if we're doing, or my wife is doing henna tattoos at a market, for example, it's not just the end results that people are after, it's the theatre of actually sitting down and going through the process of getting it done. So a big factor in this build is going to be making the henna pen look visually cool as well. So things like lights moving and such is going to make it look high-tech and all that sort of thing. However, I am aiming to give it a sort of steampunk vibe. I've got some little brass gears and things that I'm going to put on it and such, and really focus on making this pen look beautiful, but also be comfortable to use. So places like in here where it's resting on her hand, I'm actually going to coat with some soft leather to pad it and make it more nice to use. But we'll see how that goes as we get there, because it's going to be a bit of a process. So first thing I've got to do is hook my interface up to my microcontroller, get that sort of hooked up, and get my computer connected to it to make sure that I can actually get it doing something. So it'll be a little bit quiet while I do that. If anybody who does eventually end up in these streams watching wants me to describe things in more detail or explain the why of things, just let me know. Yeah, it's simple. If you've done even hobbyist engineering, you'll see it as simple, but I run into this a lot. A lot of things that I think are quite straightforward because I've been doing it a long time. A lot of people think it's sort of like magic. I'm sure that happens in anybody who's done anything for an extended period of time. But if I do get ahead of myself and I say something that doesn't make sense or you would like explained more, please feel free to let me know. It's funny, normally when I'm working I have some music going, but yeah, YouTube will get angry if I do that. Alright, so let's have a look here. Well, I'm hoping this will be entertaining. Like, this is probably the only stream I'm going to do that is actually to do with electrical engineering, unless people are like, wow, that's really cool, I'd like to see more of that. But to be honest, there's not that many electrical engineering projects that I do. One of the things that I offer at markets is, which some of my longer time followers would probably know, is this arcade machine in a suitcase. A lot of people go to markets with families, and I thought, hey, why not capitalize on that? So it's actually a fully functioning arcade machine, and I put like an iPad in there, and then I write video games as a hobby, so it's easy to put games on it. And then I link it up to this, and it allows people to play arcade games at our market stall. But, normally you're going to see me blacksmithing or doing woodworking. I may even stream some more of the creating of the actual pen element of this. We'll see how it goes. I don't know what people are interested in. So since it's only you, Sam, should Does that mean I have to start like singing Clamavi de Profundis songs? Misty mountains flow, dungeons deep and caverns old. The fires were roaring in the night. The trees like torches blaze with light. I am not very familiar with them. I listen to quite different music to you, I think. Although I am quite eclectic in my tastes. It's very much a mood thing, really. Man, I'm so chuffed about hearing about that award. I got the first award that I have ever won in my life, awarded to me a couple of months ago, and I've never been an award-winning sort of person, but getting that, man, yeah, I don't know, I mean, it's just chuffed, you know, it's that sort of recognition that makes you feel special. And it sort of validates all the hard work that you put in. Yeah, you're not wrong. That stuff does sound great a cappella. I really didn't enjoy the Hobbit movies, but when the dwarves in Bilbo's home in Bag End start rocking that, so, like, atmospheric. So basically what I'm doing here is soldering, or as Americans call it, soldering, this programmer to the pins of the micro. However, I've hit a point where I'm not quite sure, not quite confident in where the last pin needs to be soldered, so I'm going to quickly check that. The particular microcontroller that I'm using is a Arduino Mini 5-volt, because this is a 6-volt motor, so it will have a little bit closer matching to the actual voltage rates. Yeah, it's weird. It's sort of like how you look at the spelling, although this is a different example, they say aluminum when we say aluminium, and for the longest time I thought they were saying aluminium because I thought it was spelt the same, but if you go over there it's actually spelt differently. So I don't know, to each their own. The solder thing, I really am not sure where that comes from, because they still spell it the same. I will always say solder. Yeah, you're not supposed to breathe the fumes of solder, and I try not to, hence the fan, because there is a lot of lead in it, but it, I don't know, it's a very calming smell. It's a bit like the sulfur when I've got the forge running. So, let's have a look here. The ground. Don't need a reset. Okay. I guess I'm off the hook there. Alright, let's try this out. You need to have that hooked up to something. So, we'll get some main power. We'll get some ground. Every circuit needs to have an innie and an outie. You've got your power going in and your ground connection. Microcontrollers are no different. Now the reason that I'm going with the Arduino Mini is because it has very small power requirements. Now this uses is really low amp and 6-volt maximum. Then there's this, which is 5 volts and ridiculously small amp usage, and the sensor is almost negligible, which means the entire thing will be able to run off 4 AA batteries quite nicely. I do intend on building a rechargeable battery system for it in the future. However, the portability of this at the moment is one of the most fundamentally important aspects of the build because of markets. A lot of the markets we go to, we've got to walk quite a distance to get there, hence the suitcase arcade machine. And so, you know, trying to minimize weight is always a smart idea. Funny, if I keep looking over my shoulder, we've been sort of helping raise, I suppose you could describe it, a family of butcher birds. One of the most delightful species of birds ever put on this good earth. And normally in Queensland in summer it gets so hot that literally birds drop out of the sky dead. And last summer was no exception. And so this summer I was determined to not let that happen. And last summer, get in there. Last summer the butcher birds were lucky enough to have one successful baby. And we got to see it grow up and, you know, do all the peeping and complaining and I want food and all that sort of thing. And eventually, butcher birds, if you don't know, they start out with brown and white plumage and end up, once they're fully grown, black and white. And so we got to see it turn from brown to black and white, and it was successful and everything, despite the heat. And heat brings a lack of food and all sorts of things, so we try and help out with food, little bits of mincemeat and things like that. This summer, I've been putting up bird baths. I built them a little shaded shelter that actually has a water bath in it and perches to sit where they're in shade, and even like food dispenser on it and things. And they're a pest in Western Australia. People think they're a pest here because they tend to swoop you if you are near their nests during nesting time, a bit like magpies do. But most people with birds that do that, what they don't realize is they recognize your face, particularly corvids like magpies and crows. They can actually learn who you are by your voice and your face, and they can remember you. So if you get swooped by one of them, just give them some food. Make a show of showing them and putting it down and then walking away from it. And if they eat it, they will be your friend for life. They will follow you everywhere. They will protect you from other birds. They just absolutely love it. A common thing that people give them to gain their trust is dog biscuits, because that's easier to carry than mincemeat. Falcons, right? Don't get me falcons in Brisbane. But they have actually got quite crazy good personalities like you'd find in parrots. And so we've been looking after them this year with, like I said, the little shelter that I built and bird baths and things like that, because watching them literally just turn up dead in your yard is heartbreaking, especially when you love animals like I do. It's particularly birds. And not only have they fared very well this summer, they had 4 babies. So 4 little brown and white balls of fluff turned up on our back veranda one day, and they come back every day, and they sort of see it as like a safe place where predators and things can't get them. And the parents literally bring them there and then dump them there and then fly off to go hunting during the day. And these little baby birds sit and play on our back veranda, and I've built some wind chimes, and they've actually learned that the little donger in the middle of the wind chimes makes a noise, and it makes different noises depending on which direction you swing it. So they'll stand under it and hold onto it with their beaks and start trying to play music, which is really cool. And we've got just some little metal clips and things out there on the floor that they play with. So I can hear them because the back veranda is through the windows that way. I'm just down in my workshop at the moment. And I can hear them playing with the toys that we've put out for them. It always sort of warms my heart a little bit. Alright, so just getting this hooked up nicely. Yeah, here we go. It's very fiddly work, electrical engineering. And I'm not even working with the smallest components, I'm sort of using the largest stuff. Some people are brave enough to work with the surface mount stuff. I am not included in that. And this will be the last wire, and we can actually put some power into this and see how it goes. I hope, Sam, that you sort of do, I know you talked about it in your live stream, but I hope you do end up doing more of the live streams, because watching your work in real time is actually a real blast. Not enough YouTubers do it, in my humblest of opinions. Like I said, I'm not really planning to do anything but live streams and just leave them up, because I do not have the time to actually put out content, especially since I've been away a lot lately, and I've only just come back with a little bit of spare time this weekend. Not the weekend, just gone because it's Monday. Alright, so the gizmo that I'm using here is a really handy device for anybody who does electrical engineering. It's a power supply that allows me to adjust how many volts and how many amps I want to put out, so I can simulate a battery pack like this, or a lithium-ion battery, or plugging it into mains power on a wall, or by just adjusting the settings and saying I want this many volts, this many amps. And it just makes things really straightforward and smooth. So I've got these 2 output channels here. And I hook up the outie, hook up the innie, and see if it lights up. We'll see if it explodes. Sometimes it does. It's working. I don't know if you can see this. But the real test is going to be, can I program it using my laptop? Now my laptop recently kind of died. It's like one of those netbooks. It's supposed to be all like super cheap. It was like $200 or something, because I don't have the money for a fancy ass laptop. So I got one of those netbook things, and it came loaded with Windows 10 on it. But Windows 10 has mandatory updates that just keep happening at the most inopportune times. And the thing is, the netbooks come with really small hard drives, so updates take up gigabytes and gigabytes of space, and it couldn't do the updates. And because it couldn't do them, it was constantly putting up warnings saying it couldn't do them, things like that. It was just a pain, absolute pain. So I changed my operating system on the laptop to Linux. And Linux it's not Windows, but it's great for when you're using something for simpler purposes. Like, editing Word documents, live streaming YouTube. So I've had to actually get Linux versions of everything, and that includes the software that I use to program microcontrollers. So I haven't seen if this works yet, but I'm going to grab the cable and we'll try. See if I can find the cable. Everything in my workshop is covered in a thick layer of sawdust, because before I stopped doing commissions for a while there, I batched out crochet hooks, which are available on my Etsy page, link in the description. Wacky waving inflatable arm filling tube there. Anyway, so I used the same workshop because I'm a bit cramped for space. I used the same workshop to do blacksmithing, woodworking, and electrical engineering. Everything here is covered in just this film of sawdust because my workshop does not really have adequate ventilation. Okay, let's see if this works. Yeah, well, I think, if a workshop isn't filthy, are you even using it properly? That's what I want to know. You can see behind me, the tattered remnants of various projects. There's what looks like an air compressor tank. I've actually gutted that and I'm turning it into a propane forge. I've got one of the Gamerco burners. It's going to be very small inside, literally only about that, but quite deep to get the volume, because I don't like using gas forges. But two things. One, I usually only do quite small things, and it's designed to be big enough to do a butcher's cleaver if I had to do that as a maximum size thing. It's only really going to be used for jewelry, larger knives, and Damascus billets or sandmite billets to avoid the schmutz. I'm never really going to do anything big in it because I don't like gas forges. It's just they're convenient for certain tasks. But where they're most convenient is if there are fire restrictions going on, especially during Australian summers, you cannot use a solid fuel forge. You can use a gas forge with, the right precautions taken. So it'll also keep me forging. Oh yeah, really? You're showing off the crochet hooks at the show. That's awesome, man. That's really cool. I've got 2 sets on Etsy at the moment, and a third one going up soon. I've got to do some leather work for it to make the pouch. And I was thinking to turn that into another live stream, because that actually encourages me to do it. Because I've also got to do up a couple of sheaths. I'm sending a knife to a friend in Germany who sent me another care package with a heap of leather working tools, which was really quite nice of him, and I'm giving him a knife back. So that might make a nice live stream, because leather working is yet another trade of mine. But yeah, thanks so much for showing off the hooks, man. That's really cool. Alright, let's have a look here. Arduino Mini. Upload. Problem uploading to board. That's what we like to see. I'm really glad she likes them, man. It's my pleasure to make them, and to be honest, she may get some more sets arrive, or more hooks arrive at some point. Just because. no other reason. Alright, let's have a look here. We'll leave that for another time. Don't need the microcontroller at first. We just need to actually get stuff happening. So, bring you back up. Here we go. So we'll put this to one side. And we'll bring out this beast, which is a project board. Project boards are always fun. Now, I should actually be able to maybe show you. Let's have a look. Does this focus in if I do this? Kind of focuses in. I don't think I'd be able to get the wires long enough, and I've sort of mounted everything nice and stable on a tripod because I thought it would be handy. I was wrong. So, what we're going to do... we'll bring this out here. And see if we can't break something. Namely, an LED. So I'm going to take an LED. Feed 5 volts into it. I'm going to put it through my force sensitive resistor and put it out. Let's have a look. And I'll turn off these lights so you can better see it. There you go. See this? I don't know if you can. What I'll do is I'll tilt it. I'm squeezing the force sensitive resistor. And that's essentially how that works. So on my little force sensitive resistor here, there's a little pad at the end, and that pad is where the resistance happens. So on here, the pad will kind of sit on the top. And what I'm going to do is actually, I'm going to build a little, basically a mechanical button that free slides in a little channel there, and as she touches it, the bottom of the button will press against this, just so that's not exposed and visible. Because I kind of want, like I said, want this to have a steampunk sort of vibe. Ooh, I might even make it out of brass, because a very cool guy recently sent me some brass. So, what we want to do is play with our motor. One thing about DC motors is that they're actually coiled magnets, so all the little metal bits on your desk start sticking to them as soon as you put them down. What I'm going to do I don't have any tape here. I'm going to grab some tape. Good old blue. Any blacksmiths or woodworkers in the audience will be very familiar with this. Or painters. This is also a DC motor, a much smaller DC motor than the one in our peristaltic pump. But it's also a very inexpensive one, which means I can use it to test circuitry to make sure it works. And so that it's more visual for you, because I can easily see if this wheel is rotating. This is from a robot, basically. But I've got this little thing on it, so as it turns, you can see. Okay. So, to test this and show you what I mean first, before I go diving into it, I'm just going to jump these two and observe. See that? Okay. I'm going to take my force sensitive resistor, which is here. The one thing on a desk this messy, you put something down, you never see it again. Okay. Okay, so what we've observed here is nothing happening. Now, what that means is that the resistance range afforded by this force-sensitive resistor is too small to affect a motor. So basically, the motor requires a minimum of a certain amount of current in order to even start moving at all. Now, best way for me to illustrate that would be to explain how transistors work, which is a fantastic little interlude. Let me grab... I did have a book with me. Oh, here. Fantastic. Okay. Now, you're probably familiar with the term transistor, everybody listening. But what happens is basically you have voltage flowing along. Like so. Because that's super clear. Maybe we'll get a Sharpie. We'll get a Sharpie. Like I said, totally prepared for this. Alright, so that's better. Voltage flows along like this. Now, if you want to control that flow of voltage by turning it off or on again, normally you'd put something like a button in there. Now, a button is represented in circuitry something like this. So you've got your flow of electricity. It goes through like this. So the flow can only actually happen when this link is closed by pushing on the button. Pretty simple. However, what if you want that flow to be controlled by, say, a computer? A computer cannot reach its finger over and push a button. So what you have instead is a transistor. Now, a transistor is represented by this, which looks a lot more complicated. So that's one type of transistor. There's actually two types of transistors. But I'm not going to bore you all with theory, so let's just say it's a transistor. Anyway, you can turn this switch on or push this button by sending voltage to this middle pin. Now, a transistor, when you actually see one in the flesh, I'll draw a picture of one because they are so small that there's no way I'm going to get a shot on camera. But it kind of looks like a little canister like this. It's usually black. And it's got three little legs sticking at the bottom of it like this. And depending on the model, one of you've got leg 1, 2, and 3. 1 might be here, 2 might be here, and 3 might be here. This part coming out. And you literally just wire it up like that. Voltage goes in one way, voltage goes out the other way. And then in the middle, you've got one pin that you can hook up to your computer or microcontroller and pulse that pin, and all of a sudden the voltage can get through. Now, what I'm going to be doing to control my peristaltic motor is a thing called pulse width modulation, which you do not have to remember because that's a big mouthful to remember. But basically what it is it's allowing, like, for example, our peristaltic motor takes 6 volts to run at maximum speed. So if you were to put 3 volts into it, it would run at half speed. But rather than changing the amount of voltage going into it, what we can do is only ever put 6 volts into it, but change the number of times per second we send a pulse of 6 volts. So if we're sending it, like a microcontroller on average can think at like 1,000 times a second. It can send an instruction. So let's just say, for ease of explanation, it can send an instruction 1,000 times a second. So if we were sending a ping to this pin here on the transistor 1,000 times a second, essentially the motor would be on constantly, because that would always be sending 1,000 times a second. It would be sending a pulse of 6 volts to our motor and making it turn just a little bit more, because basically it's turning the motor on and off again 1,000 times a second. So to the human eye, it just looks like it's turning around at full speed. But what if we were to slow it right down and only do it 10 times per second? All of a sudden that motor is moving like 1/100th of the full speed. And that's essentially what pulse width modulation is. You send a frequency to the pin that is connected to something like a transistor. And as those pulses happen, basically the frequency at which those pulses happen allow you to dictate the speed at which you are sending instructions to your microcontroller. So that's essentially what we're going to be building, and you'll get to see it actually work. Now, I will put some circuit diagrams can end up getting fairly, is that going to focus? can getting pretty wild. So I'm going to try and keep this very simple. Bonus points for anybody in the comments that can tell me what that circuit is, although you probably saw it on the... No, never mind. So I'm going to take all this out. If you've fallen asleep, blink twice. I can... the windows behind me where I was talking about the butcher birds before, it's frosted glass. I can see the little silhouette of one of the butcher birds outside the glass wondering what I'm doing in here. You can probably hear my voice. Alright, so... Cool. To give you a reference to that drawing that, oh hey Aaron, how's it going? So to give you a reference, that was my magnified drawing of what a transistor looks like. Brain hurts. Well, I'm glad that, you know, there's clearly some entertaining content going on. But this is how big the transistor actually is. Now, as far as transistors go, this is a very, very large one. They can get so tiny that if you look at something like this, see this chip here? It's a 40-pin microcontroller called a parallax propeller. It's one of my favorite microcontrollers to work with. It has 8 cores. Like, you ever heard of a quad-core PC? This has 8 cores in it, and it's one chip. But inside that chip are billions of transistors, and they are all doing various things, but essentially the same process in different combinations, which allows the computer to think or follow instructions. That is a really large one, because if you think billions of these would fill this room, but this is what we're going to be using, and it is exactly the same technology that is in a microcontroller. This one here, Aaron, is basically, it's just a development board, so it's sort of like for prototyping and experimenting with projects. What we're actually working on, which if you end up playing back this stream later, is this one. This is one we're building. So to recap, since we've got another person in here now, what I am creating is, if you're familiar with henna tattoos, my wife does henna tattooing at markets. But she, doing it with the little cones that they always use, cellophane cones, gives her RSI and hand cramps from doing it all day because it's a squeezing action. So I tried to find a solution to that, and one doesn't exist, so I'm building one. And what I'm building is a pen which she can hold like this, that is hooked up to a peristaltic motor, which you use in hospitals to dose medication into people's veins. And basically it'll suck up small amounts of henna and pump it down into the nozzle of the pen, allowing her to do henna tattooing. Now it's being controlled by a pressure-sensitive switch, and this is what we're talking about here, is how the pressure-sensitive switch will be linked up to the motor to control its speed, because the faster the motor spins, the more henna pumps through it. And so having that control allows you to do more accurate henna art. So hopefully that is sort of like a good enough recap. So, well, henna it's temporary tattoos. It's sort of like, it stains your skin for maybe a week, maybe 4 or 5 days. If you're a redhead, it actually lasts quite a lot longer because your pigment in your skin works differently. So, yeah, it's something that didn't exist, needed to exist, because my wife was sick of getting hand cramps, and so I'm building it for her. So, that's kind of where we are. And normally my videos won't be here at an engineering desk, they'll be at my forge or doing woodworking, but I thought this might be a little bit interesting because it's something that I had to do anyway. And occasionally you got to build something. So, Yeah, let's get back to it. Alright, so we've got our transistor here. And I'll show you how it works. The main reason that the first live stream is here is because it's still quite hot here in Brisbane. Although it did wake up to rain this morning, which is nice. It means that there will be a blacksmithing session hopefully very soon. And I've got a few things to catch up on in that regard, so I'll be doing a live stream of blacksmithing when that happens. So, trust me, I'm only in my 30s and I'm starting to need one. There's actually a thing that I really want to have, but I can never justify actually forking out for. It's called a handy hands. And it's this thing that's got a weighted base and a little arm with a big magnifying glass on it. And it's got all these little alligator clip hands, so you can actually bend them into different positions. So you can hold these things for you, keeping your hands free. And you've got a magnifying glass so you can see it up close. They're really handy. So now, because I'm working with a motor, the peristaltic pump is actually quite a, it's an expensive piece of kit and I don't want to blow it up. So in order to avoid doing that, I'm using this cheap, nasty motor, and I've put some painter's tape on the outside of it, so when it spins, you'll actually see it moving, because if I just left it at the wheel, you wouldn't be necessarily able to see it, but with that painter's tape, you can see it turning. Do you have a handy hand, Sam? I actually used to have one, and I lent it to somebody, and never got back, and then they disappeared. They must have needed it more than me. Okay, so get our buttons, a nice little clicky button. See this? Watch here. So, let me see if I can get you close to show you what's happening here and explain some transistor theory. Okay. So, what we've got here is our transistor in the middle, and the transistor has that pin like I showed you going in, and it's controlling the voltage going through. So I have 5 volts coming up through here into one side of the transistor, and out the other side I have the 5 volts continuing to this motor, which then goes to ground. Now to control the transistor, I have a button here, so that's going from 5 volts through the button and then into the transistor. So when I press the button, the motor spins. Now, what we're going to be doing with the peristaltic pump that we've got here is controlling its speed in this manner. So
we're going to always be putting the same voltage through it, which will be 6 volts in this case, not 5. But I'm going to be pressing the button. See, if I go really as fast as I can, the motor may as well be spinning constantly. But if I press it only every so often, it goes slower. And if I do it really slow, it goes really slow. What we're going to be doing is programming a microcontroller to handle the rate at which the button is pressed by sending signals into this transistor, and it'll do it for us.
That way, I'll be able to very precisely control the speed at which my peristaltic pump outputs the henna, because this thing actually only spins quite slowly. Because peristaltic pump is designed for dosing medications that need to be very small amounts. So what we need to do is go at its maximum speed. It'll be quite slow, but no, I don't use binary code. I use, if I'm using a propeller, it'll be a language called Spin, but what we're using is actually an Arduino Mini, so it's actually done in an Arduino language. I can't remember what it's called. But does that concept make sense to you guys of what's actually happening mechanically there or electronically? That's awesome. I'm often told that I explain things too fast and people lose track of it. So if it makes sense to you, that is awesome. I try to be as clear as possible, but a lot of the time I forget that people don't know certain things that I take for granted. It's one of my worst qualities, and I tend to carry on ahead when I shouldn't. So always feel free to stop me. That's cool. It's a really elegant way to control the speed of a motor with precision. When you think about it, if an average microcontroller is doing up to 1,000 instructions per second, that's a lot of degrees of yeah, well, Sam, that's how I feel when I see you bladesmithing. So, yeah, I mean, there are motors that are designed specifically to have their speed controlled, and they are called stepper motors. This here is a stepper motor, and they're a lot more complicated because look at all the wires coming off this thing. These are all just for one motor, and the way they work, and I know this is a huge deviation from what we're talking about because I'm not using a stepper motor, but I find this stuff cool, and while you're here, you're trapped listening to what I find cool. So, if you've ever been interested by clocks and clockwork mechanisms, you'll know what a release is. So, inside of a clock, you've got all these different gears, but the most important one is called the release wheel. And a release wheel actually has this sort of thing on it. If you can imagine, look at this hugely accurate cog that I just drew. But on top of it is this thing that looks like that. And so long as there is force being exerted on this wheel making it spin, which in clocks they actually use this sort of wrap string or chain around the axis and hang a weight off of it, and as the weight pulls down, it makes the cog want to spin. The release goes tick, 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 grabbing onto the teeth of the cog. Yeah, exactly. It's the thing that makes it go tick-tock. Inside stepper motors, they actually have toothed wheels attached to the drive axis of the motor. And instead of something like this, which has 4 little magnets in it, which basically it pulses which magnet is on. It goes, and that makes the motor spin. So there's not much torque in them, really very little torque, because you're just working on magnetic pulses, which is why this sort of motor is really easy to just grab and do this with. The stepper motor, you can, but you can feel the tick-tock, tick-tock, tick as you go around on it, because instead of having just 4 poles of a magnet, it's actually got these little teeth around the teeth wheel, these little tick-tock things basically that are grabbing the cog and turning it using magnets still, but they're doing it at 4 poles, sometimes 2 poles, sometimes 6 poles. But the number of teeth on that wheel actually translates to a number of points of rotation as it goes around. So different stepper motors have different grades. So basically, if you need a motor like this one to say it's pointing up like this, if you have a particular mechanical need of a device to point exactly 90 degrees like this, and you're using just a normal DC motor that's run off magnets, there is no way you can precisely get it to go from there to there without a whole heap of other circuitry like magnets on the wheels that can actually, like as it turns around, that point in the wheel hits the magnetic sensor and goes, oh, it's at 90 degrees or something like that. The motor itself can't do it. Whereas this motor knows how many teeth are in that wheel, and so it knows exactly how many steps it needs to make to go from 12 o'clock to 3 o'clock. It knows, and you can just say, I want you to make that many steps, and you know that once that code has been executed, it will have turned exactly 90 degrees. And you see these types of motors used in 3D printers and CNCs and things like that, because this head needs to move at very precise things. Well, windshield wiper motors often do use a form of very simple stepper motor, but what they have is a mechanical sensor. So it's sort of like a button here and a button here, and as it turns, it goes and it hits that button and goes, whoop, need to change polarity, and it goes the other way, and then hits that again. More advanced cars, more modern cars, they have a bit more intricate than that, but for years it was just like DC motors running a gearbox. That's how they got the torque, because if you take a normal DC motor that's just running on magnets, and you make them fairly powerful magnets, but then feed the output through a gearbox, you can get quite good torque off one of these. This actually has a very small gearbox on it. The DC motor's in the back here, and it goes through a little plastic gearbox. But this is just for small robots, so it doesn't really need to be that powerful. This one here actually has a DC motor that fits in the bottom part. This top part here has that motor geared down, ratio geared down massively, and it's all using metal gears, because these things, people's lives literally depend on the torque that these output. Because if you get a particularly thick bit of gunk or something in what you're trying to pump, you can't have this skip and miss a dose. And so it's all metal gears. They're very, very cool. Funnily enough, they're like $6 for one of these. They're not an expensive part, yet they're literally keeping thousands of people across the world alive. And I kind of find that cool. But anyway, that's the difference between a DC motor and a stepper motor. Now, I could have used a stepper motor for this part, and you'd think, if this is keeping people alive in hospitals, why don't they use stepper motors for peristaltic pumps? And the answer to that is actually just money. These are really cheap. DC motors are a dime a dozen. You bulk order these from China and you'll end up paying 30 cents each. These are always expensive. You're looking at $20 or $30 each for these, for good ones, for proper decent ones. And so it's not often that you'll actually find a peristaltic pump that uses a stepper motor. What they do instead is use what we're creating, which is pulse width modulation. Because if you've got it nicely heavily geared with metal gears, the odds of it slipping and skipping doses are so infinitesimally small that all you have to do is place a flow rate counter on the output of it to make sure that the fluid has actually passed through, and then time that up to the code. And that way, if it skips a bit, the counter sees that it skips a bit and just pumps more. It's cheaper and it's easier to produce. Most things are built as cheaply as possible when they're mass produced. And so very, very clever people come up with a way that you can reliably make something cheaply. And so you get essentially kind of what we're doing here. So the pulse width modulation process allows you to turn the motor on and off at a very specific hertz rate, essentially. So if we were doing 60 hertz into our pulse width modulator, it's going to turn that motor on and off again 60 times per second. And how long it turns it on for is going to be determined by what transistor will be used. We're using what's called a 2222N transistor, which makes no sense to anybody that's never done any electronics before, but it's a very common, very cheap one. I wanted to buy one for this project. I couldn't buy one. I had to buy a pack of 50 of them for 37 cents. So that was expensive because I didn't want to wait to have it come from China. So once you've actually got the gear to do the building and like prototyping boards and everything, the actual parts for electronics are dirt cheap. However, the work involved in making anything means you really can't turn it into a profitable business unless you're like repairing people's TVs. Fun fact about that, most of the time when your TV dies, and if we're talking, or computer monitor, we're talking about LCD, the flat screen TVs, most of the time when they die and you have to then go and spend $1,500 to go buy another one, all you actually had to do to get it working again for another 10 years was replace one electrolytic capacitor, something like this. I've kept my TV running now for 18 years. It's died 3 times, and then I get one of these, find the one that blew, replace it. Keeps going. You have to find the right one, of course, but if you know what you're looking for, that's very, very easy. And so and my computer monitors are the same. I'm really cheap, so when things break, I try and fix them first, which I think is a good motive. I think living in kind of a throwaway society, it's good to actually try and fix things. There are a lot of things I can't fix, and a lot of things that are well beyond me. I know that me sitting here talking about pulse width modulation and peristaltic pumps and DC motors and things makes me sound like I'm really, really smart with electrical engineering. I am an absolute beginner. Absolute freaking beginner. There are people I know that run circles around me. I'm just a hobbyist, really. And like I said, this channel is not about electrical engineering. It's just kind of it's a hobby of mine. And this was a thing, I was sick of seeing my wife have to like stretch her hand and get sore and get shakes after doing henna all day at a market. So I've said, you know what, I can fix that. And that's what I'm doing. So the process that we're going to use is this, and actually Aaron, you wouldn't have seen this because you came in a bit late. We're using this little thing. Now this wonderful little device is called a force-sensitive resistor, and basically all it does is it measures squeeze on it. So we've got this pen that, this is my template. I'm going to make quite a nice pretty one, but this is the template that fits in her hand. And here, where I've marked on the side, that's where her index finger rests. And this is going to sit there, and as she squeezes it with her finger, it's going to control the speed at which our peristaltic pump operates. And it's going to be very sensitive, so with very little force being applied, she's going to be able to very smoothly and fluently and intuitively control how much henna is being pumped through the system. And that way there's no strain on her hand, and she can just do it all day and not get a sore hand. So getting those sweet husband brownie points. You know what I mean, married men out there. So the process that we've got to actually do, third time it's a target, I like that. So the process that we've got to do is connect the force-sensitive resistor to our microcontroller. And the microcontroller will constantly be watching how much force is being applied to that force-sensitive resistor. It's going to measure that and place it into one of, say, 3 or 4 pressure ranges. Each one of those ranges is going to be attributed to a certain speed of our peristaltic pump. So it's the lowest speed will be agonizingly slow. It would maybe be something like 5 hertz, and then the highest speed will basically be the full speed of the pump. And as she squeezes on that button, it will control the speed of the flow. I may even get clever with it and try and turn into a thing where I make it an infinite range, like a direct correlation from pressure to that. But to keep things simple, I'll probably just make it maybe like 4 or 5 speeds. And what I'm going to do is I'm going to link each of those speeds up to a light. So there'll be a little light bar on the pen, on the top of the pen. So as she's holding it, she'll be able to see how many lights are lit up. So when she's not holding her finger on there, none of them will be lit up. When she's pushing as hard as possible, all of them will be lit up. And that way she's got a visual indicator of how much force she's doing. It will be redundant after she's been using the pen for a while and is used to it. Until that point, though, it's kind of, she needs to train with it. She's never used something like this before because it didn't exist before, but we're building. So this is our pulse width modulation system. And unfortunately, at this point, I can't do much more until I can connect my microcontroller to my computer. And because I'm using a Linux laptop, I think it's going to misbehave. So it may end up being maybe a shorter stream than I thought, but it's still an interesting one, at least. But we can at least get all the parts connected up. And the next one is getting some nicer wires on this force sensitive resistor. Love that smell of solder. Now I'll put some green wires in there, I think. I taught my wife a little bit of basics of electrical engineering because she wanted to build some Christmas decorations for herself. And because it's Christmas decorations, she wanted to have green and red wires Christmas. So once that was done, I had heaps and heaps of green and red wires lying around. So I'm trying to make use of them. Normally in electrical engineering, a red wire is for your power and your black wire is for your ground. But I'm not doing that. Green is ground. I'll be back in just 1 second. Heard the postman. Right. Sam has tea breaks. I have postman breaks. Funnily enough, some of these are probably parts for this project because I ordered them. Oh, there you go. So I'm valid for US power. Yeah, I ordered the parts for this, and they were all supposed to be here by last week. They did not show up. Ooh, there you go. That is for this, and it may help. We may be good to finish this anyway. This is also for that. These are actually the specific transistors that we need for this project. My little example here, I was using one that was inappropriate for it. I always hate when things turn up late when you order them. Ooh. I was actually just talking about this with Sam at the start of the podcast. A friend of mine in Germany has been sending me leatherworking gear. And I thought it had all turned up. Oh, that's nice. Look at that. Stitching punches. That's quite nice. Nice little case and everything with it. That's cool. I always buy the cheap, nasty tools. Anyway, we're on now. We got the things that we needed. How good a timing was that? I'm just saying, like, hey, we may have to stop. And then it all turned up. Posty was grumpy too. I took too long to get out there, and he was writing the little, you know, the dreaded slip. How bad is that when you're waiting for something, and then you get home from being out or something, and you find the dreaded slip, and you've got to wait and go to the post office. My post office is a while away. Yeah, I will be doing, my next live stream will be on leatherworking, because I've got two things that I've got to do. One with soft leather, one with quite firm leather. So, well, you can make your own because you're a very talented smith. Maybe I'll send you some because I've got doubles now. It's the one thing about care packages, they're intended very well, but oftentimes contain things that you already have. So, you know, you can pass the joy on. Have people, have other people enjoy them and get some happiness out of them. What was I doing? Here we go. All right. Now, to protect my little sensor here, I've got, yeah, there it is, heat shrink tubing. This stuff's super cool, and I wish that I could show you up close if you've never seen it work. I wish I could show you it working. Basically, you cut a little sleeve of it, the width that you need, and you slip it over your wires where you've done your soldering, or Aaron, for you, soldering. And then you apply heat to it, and it constricts down and creates a rubber shield that covers the electrical components. Actually, you're not wrong, Aaron. A fork is about the right size. Now I just need a heat source, so I'm going to use a match because I don't know where my lighter is. That moment where the head of the still burning match lands on a floor that's encrusted with like an inch of sawdust. That was well thought out. Do as I say, not as I do. Yeah, when I send you your tobacco packy, Sam, I'll send you some punches because I've got doubles. So I've got a couple of doubles actually of a couple of tools, so you can have them. The tobacco packy will be coming this week. Soldering is like forge welding on a microscopic scale. Okay. Now that we've done that, it is time for me to see whether or not this works with our little brain thing that we made. Some people stand in darkness, free to step into the light. Some people need to have somebody, the edge of surrender inside. Don't you worry, it's gonna be alright. 'Cause I'm always ready, won't let you out of my sight. I'll be ready, and when you know it, don't you fear, I'll be ready, forever and always, I'm always here. There are two types of people in the world, those who think that Baywatch is glorious, and liars. To be honest, I'm super chuffed that I've got 2 people watching my first stream. So thank you guys for being here. I hope you find it interesting. To me, all this stuff is super interesting, but that doesn't necessarily mean that other people find it interesting. But since this is for my wife, any married man will tell you, happy wife, happy life. My wife and I have been together 11 years this year. Well, I'm glad. Thank you. It, to be honest, helps motivate me a little bit because I'm not the best when it comes to motivation. I struggle with a lot of depression and things. Not really anxiety, which has never been a problem of mine, but yeah, that depression bear is hard to get off your back, and that stops you wanting to work. And having such wonderful company while you work makes things a hell of a lot better. "28 years. Woo! Good heavens. That's impressive." It's funny, I used to suffer from anxiety quite a bit as a teenager, but when I was in my early 20s, I have an illness called Crohn's disease. And a lot of people can live with it their whole lives and it's fairly mild, but some people have a rare case of it called extracolonic Crohn's, which can kill you at seemingly random times. And mine's tried a couple of times, and the last one came exceptionally close. They said I had an 87% chance, according to the odds, based on past patients, 87% chance of dying on the operating table. But as you can see, I survived. And after going through that, nothing worries you anymore. It's a strange thing. You just, natural disasters, people trying to mug you, fuck off. It's just nothing bothers you. Doesn't help depression though, just anxiety. Man, your streams were a godsend for me. Like, it's been a bit of a rough couple of weeks for me, and getting to sit and watch those has been bliss. It's really nice, and it kind of low-key feels like I'm hanging out with you, which is nice for somebody who doesn't have friends, at least in the come over and visit sense. By choice. I'm a bit of a hermit. I'm a lot of a hermit. I'm also a know-it-all and quite abrasive, so that doesn't help my chances. Yeah, you're one of very few people who agrees. Okay, so I don't know if you can see this, but I've got the microcontroller here and all of the necessary wires coming out of it onto my prototyping board. I now have this thing which arrived in the mail, which is a much better version of the device I was using, my little homemade one that allows me to plug the microcontroller into the computer. This is the proper one, and I found a place that was selling them for $6, and I thought, well, that's a bargain. Much better than my dodgy homemade attempt. So hopefully this works better. Yeah. No, I get the feeling after I feel like I know you quite a lot better after watching your streams and seeing so much of your process, and I see a lot of similarities. Like, I'm starting to wonder if we were separated at birth. Let's have a look. So, ground goes to there. We're gonna need more wires. Where are my wires? Wires. Yeah, well, that's. I was trying to explain this to Sam. That's exactly it. Like, when you're someone like me who's just sort of working out of your garage with tools that are half of which or more are hand-me-downs, it's you watch things like Forged in Fire, in that last stage, you get to see people's home shops. You see these people, power hammers, multiple power hammers, hydraulic forge presses, big like sword forges with 4 burners or ribbon burners, or huge workspaces that are like 30-foot by 50-foot sheds that are air conditioned and all that sort of shit. And of course they're able to turn out Damascus billets and full-size swords and things like that. I mean, power to them. They're great at what they do, and they deserve every bit of it that they have. But when you're a guy like me who literally just has a solid fuel charcoal forge, like I can't even get coke for my forge, so it's charcoal, hand blown because blowers are expensive, working off a tiny little anvil with hammers that aren't really supposed to be used for forging, but you make do because you love it, you enjoy it. It's about the passion, it's about having fun, it's about getting to make beautiful things, and beautiful is subjective anyway. So like, my knives have this sort of weird organic feel to them that I do deliberately because that's what I like. Like, if I showed that to someone like Jay Nielsen, he'd probably scoff at it. Don't care, I enjoy it and I have fun with it. But watching Sam's videos, it shows you, like, he is making knives that are of the standard of that sort of level of competition. Like, he's gone through ABS testing and things like that. He can go to shows and winning awards for his work, which, congratulations again, Sam. Very well deserved. But the thing is, when you get to watch those live streams, you're watching a guy who's just an Aussie bloke, most of the time barefoot in his forge, brave man, working with the same beat up shitty hammers at the beginning. He makes his own hammers now, so he's got nicer ones, but and for a while a broken anvil, which was no power hammer, no press, hours of dedication and attention to detail and love of his craft, and out come the most beautiful creations. Like, particularly my favorite of that last batch of the live stream was that horn-handled hunter. The hours of work to just sit and work on just that brass butt cap that matches the profile of the horn blows my mind. Like, if you had just shown me the end result product of that, I would have thought, yeah, sure, that's come from somebody that's got all of this machinery and equipment, and it looks like Alex Steele's workshop. But no, it came from Sam. And not only does he go through and make these gorgeous things, he just relentlessly pursues getting better. He wants to do better. He sees a knife, and it is a bit of a flaw of his, but he only sees the flaws. But I see works of art done by a man that has nothing but his hands and nothing but passion and dedication. And as somebody who likes working with his hands and is doing similar things, it's hugely inspirational and motivational. And like, I personally never want to get ABS certified for my knives. I don't consider myself a knife maker. I like making beautiful things that are functional, and that's kind of my vibe. So he'll never have competition from me in that. But the lessons that he imparts by what he does to get to the level that he is at, using everyman tools. Like, the fanciest tool he's got is his fire ant grinder, which totes jelly, by the way. It's just, you can't fake that. You can't luck your way through into a beautiful piece of work like that. It's just dedication and concentration and persistence and getting back up after every single mistake that gets made, and thinking, you know what, this thing needs to exist, and so I'm the only person on the planet who can make it exist. I'm going to do it with whatever limited experience and tools that I have. And so watching that live stream series was like, I've been following Sam on YouTube for ages anyway, quietly. He started talking to him because of the live streams, really. But getting to actually see him do it live, interact with him while he's doing it, and hear it amazes me how many people will do a craft, especially like Yeah, man, Aaron, you hit the nail on the head. But I think a lot of people like Sam and I, and probably you by the sounds of things, have the same understanding that when you get an idea of something in your head, that's it. The decision's made. That thing now has to exist. And nobody else can see that image in your head. No matter how good an artist you are, you're never going to capture it, because in your head you can see not only what it looks like, but if it's a knife, for example, you can feel what it feels like in your hand before it exists. You can feel the weight of it in your mind before it exists. You can see the way the light hits it, and all you see when you look at this pile of raw materials in front of you is the potential of what that's going to turn into. And that's why I love the timber store that I'm always going on about on my social media that's near me, Natural Edge Timber over at Albion in Brisbane. It's just a room full of possibilities. And I don't see the pieces of wood, I see the things that I'm going to make from them, and they have to exist because nobody else can do it. I could describe it to somebody else, a master craftsman, that would be able to do it due perfection. And I could describe it, I could draw it, I could do all of this, but they would never get it the same. They couldn't do it the way I do it. And it is, yeah, it's totally worth it. Well, that's it. Like, a big part of my background is in psychology, and I do a lot of lecturing on, it's kind of like life coaching. However, when I say that, people think that I mean like the career line of life coaching, and that's not what I do. That's a load of BS. What I do is kind of how to adult properly, if that makes sense. I do lecture series at graduating university students as a behavioral psychology expert to tell them how they should live. And there's a point that I get to in all of my lectures where I ask them what I call the most difficult question that you've ever been asked. Because it really is. And the last lecture I did this, I asked the question and two people at the back started crying. Oh, I felt bad. But the question is, if you could go back to the day that you finished your high school, or I don't know what they call it in America, senior school or something. Anyway, you're leaving school and you're going on to maybe start university, maybe take on an apprenticeship, maybe travel a bit or something, whatever it is. If you could go back that day, the day that you finished, knowing everything that you know now, having had all the experience and everything that you've had since then, but you could take all of that knowledge and go back to that day and then live your life back to this point, this age, would you still be doing what you do? Would you be living where you live? Would you be associating with the people you associate with? Would you be with the same partner? Would you be in the same field, in the same progression? Would you be doing the same degree? Really, the two parts of that question you need to ask yourself is, A, what would still be exactly the same? What would you have gone out that first day and gotten immediately and not messed around, just gone straight to it and said, I need this back in my life. This needs to happen. I need to have it immediately. And what parts of your life would not exist? Would you actively work to have never had happen or not be around now? It's a very, very difficult thing to face, but it gives you a guide of where you should be. And I can guarantee you, if I could go back to the day that I finished high school and do it all again, I would have picked up a hammer immediately. I would have just dropped everything and I would have picked up a hammer and started forging. I am never happier than when I am in my forge. And I've known this now for years. This isn't some passing phase. I've been blacksmithing now for about close to 5 years, and it just gets better. Yeah, exactly. Most people, it would be a different timeline. Anybody that tells you the answer to that question is, no, I wouldn't change a thing, everything's absolutely perfect, is lying to themselves. And the lies we tell ourselves are the most dangerous lies. Because I guarantee you I would go out and find my wife. My dog, my closest friend, died last year. And if I had have just gone straight out at the end of high school and found her, I would have found my dog Evie as well, because Evie was my wife's, and I would have had more time with her. So everybody's got something that is perfect, it just connects, it resonates with you. If you wake up thinking about it and go to sleep thinking about it, then it's the right thing for you. And for me, that's blacksmithing. Or just making things that get used specifically. A lot of blacksmiths make decorative work, and that's great. Roy from Christ-Centered Ironworks makes the most beautiful things like bowls and statues and things, and it's very inspirational to see. But what I like making is things that get used, which is what this whole project is about. Like, it's a very simple thing, as you saw. Like, you guys have never done electrical engineering. I explained the whole concept to you, and you're like, yeah, that makes sense. I could just make this really ugly and simple and everything, but I want it to be beautiful. I want it to feel nice to use. I want her to have joy every time she's got it, she picks it up. And I want her to be connected to it on an emotional level. Yeah, that's right. Yeah, what Sam said. The more you stream, the less you get done. So that's kind of my mission, man. Like, everything that I make is designed to be beautiful as it is functional. And that's it. The knives that I make, yeah, that's it, Aaron. And so asking yourself that question, that most difficult question you'll ever ask yourself, it starts making you think more about those questions and the decisions and the answers to them. Well, I'm glad, man. It's why my knives will never be as beautiful as Sam's. Because, Sam makes literal works of art. You could put them in galleries, and they'd probably sell from galleries, and I would recommend that, Sam, because people do buy knives from galleries. You make a nice display to put that in, and people would have them in their house. But the thing is about Sam's blades, they're actually sturdy and durable enough that you could take them on like a military outing and they would stand up to it, which is really cool. The thing is, if I ever got one of your handmade knives, I would be devastated if it ever got a scratch on it. So I make like the prettiest beater knives that I can, and they'll never be gorgeous, but they're sturdy and they're rugged and they're beautiful. They fit in the hand nicely. And the same thing with, like, if I'm making a stool, I want it to be a joy using that stool and sitting on it. If I'm making, like, I make pipe tamp kits for pipe smokers, and that's a thing. Every time you smoke a pipe, you've got to use a tamp. It's just part of this pipe smoking process. So why not have a beautiful one? So that's my goal. And beauty doesn't always come visually. Sam is actually on exactly the same page with me on this. The handle shape of my knives, I will sit there for hours shaping them so that they fit perfectly. Like, just absolutely, it's like the souffle of handles, so it just disappears into your hand. And watching another smith on the live streams go through and be that finicky about the same process like I am it was kind of validating for me, because yeah, I know they're designed to be, and because you make them out of things like files and things, they're going to be hard as nails. They're going to be indestructible. Which, at the same time, though, if they're that beautiful, I'd be terrified to actually dirty them up. It's like, I don't know. Maybe I'd just be protective over it where other people wouldn't be. Like, maybe it's because I know you and I would value the knife too much and wouldn't want to use it. Like mine, you haven't spent that much on because it's just a beater knife, so you don't. It doesn't matter if it ever gets scratched up or something. But I don't know. I'd get so protective if I had one of your knives. Like, maybe use it to open packets of lollies or something like that. Something that beautiful should stay that beautiful. They're just so nice. Like I said, I've said it before and I'll say it again. It's no surprise to me that you won an award, mate. They're just so stunning. Yes. Yeah. I'm just wiring this up so that we can actually test it and see whether or not my crazy Linux-based laptop will actually connect to this thing. Okay. Red goes in, black comes out. Got our 5-volt board. Got our 5-volt line. Got this goes here. See if this blows up. Well, it's not blowing up, so that's good. So now let's see if I can connect to it. Yeah. There's two types of smoke in electrical engineering. One is like a and the other one is like a If it's black or grey smoke, it's a cheap component that's died. It's frustrating, not life-ending. It's blue smoke. Woo! That means something very expensive just blew up. Yeah, it is entertaining, but it's also horrible. I'm gonna use a different cable. I don't trust this cable. Ooh. Ooh. I may have blown it up anyway, so let's just see. Alright, it didn't blow that up. Yeah, I think we blew up the interface. Shouldn't have done. There's no reason for it. The light did flash and then stopped. There's nothing wired badly. However, I did buy a really cheap and nasty one of these things. And it could be a situation where I should just actually pay some money and get a decent one. Gotta have money for that though, so it's a two-part process. Well, we'll see. Sometimes these things just get weird. believe it has entirely crapped itself. To use the technical term. No blows, no shorts, just... I think they just sent me a dud, to be honest. Fun! Good ones are like $17. It's really not much. I'll be able to get one at the end of the week. I've got some commissions coming in. But all is not lost. I may have another one. This one is not designed for this purpose. However, it may work. One of the benefits of having done this for so long is that you sort of build up this pile of just spare bits. Here's a live stream question for you, Sam. What's the fart etiquette? Do you do it away from the mic? Do you hold it in? I've just been letting them free, have you guys noticed? I'm not telling, Sam. You've sent me enough. And you're sending me more stuff. It'll be fine. At the end of the week, I'll get another one. A decent one. I've got some orders coming in. Although I appreciate the sentiment. Oh, I better not mention them then, hey. Okay. Ooh, pretty lights. Still working. Alright, let's have a look.
To be honest, I think it's just the fact that I'm using a Linux laptop. At least this one didn't burn out, it's still good. This is one that's usually used for these microcontrollers on the back here. But to be honest, it's still been a good stream. There may be more parts to this, but if you do follow me on social media, you'll get to follow along with how things turn out. And if you follow my wife, Nissa, she's got Nissa_handcrafts, Nisse, Nissa_handcrafts, but her henna tattoos are Nissa_henna, which is HENNA. She's on Instagram, and so am I. I'll put links in the description below of this, but I'm on Instagram, I'm on Facebook, and you'll get to see build photos and updates, and probably some videos as well. I won't bore too many people with live streams about this, because really it's not really what I do. It's probably a bad thing to do as my first live stream topic anyway, but at least it has been interesting and educational. Well, you never know, I may do more streams on it, especially once it's actually all kind of working. It's the calibration process as well, which is going to be cool, because once I've actually got all the circuitry wired up on the rough prototype, then I've got to actually get the finished one of these built. And I've got some really nice woods to go through to think of for using on it. And there'll probably be some brass worked in there, maybe some like copper tubing and things just for decoration, because I'm going for the steampunk look. But yeah, it's going to be an interesting build, and the theory, at least we found out here, works quite well. That pulse width modulation controlling the peristaltic motor, and off camera I have tested this with henna. It pumps the henna beautifully. It just seems to be just the right viscosity for it. So yeah, hopefully that works out quite well. But yeah, thanks for joining me, guys, because otherwise it would have been a very lonely stream without you guys watching. So although it looks like Aaron's lost, but left, I should say. Oh no, he's still there. Good Aaron. That's the thing about peristaltic motors, they're never that powerful. So I can actually hear the butcher birds out there waiting for their supper. They come at about 3 o'clock every evening for their supper. So it's probably about time I finish this. 2 hours is a pretty good amount of time for a live stream, I suppose. But yeah, I'll do another one soon. The next one will be on leatherworking, because I really need to actually get on top of my leatherworking. I've got one more set of crochet hooks that needs a pouch, and a knife that I'm sending to somebody in Germany. It's a Viking sax, but it's like a pocket sax, blade length of about 3 inches, but a full size, full tank handle. He wanted it sort of nice and heavy, and it's nice. It's a portable little sax, so I'm doing a nice little equivalent sheath for it to match it, and yeah, that'll have to be done in the same stream, which will be good, because the crochet hook pouches are made of calf skin, genuine calf skin, and my sheaths are actually made of kangaroo leather, which I hand dye, and that will be shown live stream as well. I love dyeing leather. It's actually a surprisingly meditative process. But yeah, thanks very much for joining me, guys. Sorry it hasn't been a really visually appealing one, but there's some pretty cool theory there, and a little intro to electronics as well. And yeah, thanks for being here, guys. I'll probably won't be too long before I do the next one, to be honest. Next few days. We've got a lot on, but it's good to take a couple hours to do this sort of thing every so often. So yeah, I think I'll call it at that, and I'll leave this one saved so that people can watch it post, and then see, maybe get a few more subscribers join in for the next one. And I'll say this not for the people in the room, because they already know about it. For anybody watching this later, Sam Towns, the guy that's in here, does great work on his channel, so go check him out. Especially try and encourage him as much as possible to do more live streams, because they are awesome. And yeah, I'll see you all for the next one.